Hey guys, welcome to the workshop. I'm going to be talking about my Sencore VG91 and crack it open and try to fix it. It died about a week ago and I thought I could carry on without it, but very quickly I'm realizing how much I came to depend on it. I want to start out by talking a little bit about what it does and why it's so useful. And actually before that, talk about test pattern in general. Somebody asked me recently, do I know of an inexpensive way to generate test patterns and can I talk about it? Well, there's test patterns and then there's test patterns. Yeah, you can cobble together something pretty easily that generates a test pattern on a VHF channel 3 or 4. For example, if you have a DVD or Blu-ray player that can take a flash drive, you could download a JPEG of a test pattern or an MPEG clip of one, put it on a flash drive, pop it in the player, and display it. Or if you've got a streaming media device, you could do something similar with that. Or get one of a myriad of cheapo little pocket test pattern generators. I think there are even some that might still be being made, where it's almost like a Raspberry Pi and an RF modulator kind of thing. Those are all well and good if you have a functioning TV and you just want to tweak some of the settings. And you can get broadcast quality pattern generators too. I've got a Tektronix, I think it's a TSG 170A or something like that I talked about a while ago. And I was thinking I could use that, but then I realized, oh, it's not quite the same. See, that'll produce really high quality broadcast color bars and grids, and you can program in a custom station ID, so it'll be in the corner. But it just puts out composite, I believe, and you attach an RF modulator to it, and you can hook it up to the antenna terminals on channels 3, 4, 5, and so on. But those aren't really good for on the workbench when you're troubleshooting a set, because they just put out fixed level RF modulated video and that's it. Well, what if you've got a problem and your set the tuner isn't working? Well, what good is that going to do you? None. What the VG91 can do, well, with more importantly with the companion TVA92, is create signals that you can inject in various places. Now, the VG91 on its own will output RF on any channel, VHF through UHF. Now, one nice thing it can do that the other generators can't, some can, some can't, is you can control the output level, low, medium, high with a variable range, which is handy for troubleshooting. It also has a composite output, 1 volt peak to peak, but it has various modes, and you can select to send out IF modulated video, or just the sound carrier, 4.5 megahertz. And it has multi-burst and some other modes of generating signals that you can inject. However, you only get RF output or the 1 volt composite. What the companion piece underneath it will do, it has an amp that will do up to 200 volts peak to peak, and you can inverse the polarity, which means you can drive the grid of, say, the video amp, first video amp or the second video amp. Sometimes you want the polarity to be one way or the other. We'll also generate horizontal and vertical drive. So say your set's working, but the horizontal output stage, our oscillator isn't working. Well, you could drive the grid of the horizontal output tube directly from the TVA92. Also, it's built-in flyback and yoke ringer. Also, has built-in variable DC power supply for supplying a bias if you're doing an alignment, and a few other goodies as well. But TVA92 is a brick without the VG91, and they connect with a ribbon cable. There's also, I think it's a model 93 for doing VCR, something I don't think I'll ever get into, but just so you know that there is another companion piece. So, I am going to pop open the VG91. I've seen a few other videos I reviewed where somebody did open it up, so I have some idea what to expect. Now it turns on. That's why I didn't realize it was working for so long. It turns on and the display works and the audio output works, but the composite output is completely dead and the RF output is dead. Mostly. I did notice if I go into one of the color modes, like the color bar mode, there's a little itty bitty hint of an output. So maybe that's the color burst leaking through or something. So what I'm hoping is that everything is functional except for something minor, like the part that actually generates the test pattern, like the output stage or something like that. We'll see. I don't have any service info. I don't know that I don't think it's freely available, so we're working a little bit in the blind, but let's see what we can find. So I'm going to, unfortunately, climb up on the workbench, disconnect everything, and get it down here and open it up. Yeah, not exactly easily user serviceable in there. Much bigger power transformer than I was expecting. I'm seeing 95s on the chips. A bit newer than I thought. Oh man. Well, here's a power supply. Oof. Yeah, this surface mount stuff. I think socketed are some EPROMs. It's a good old 2206. It's probably what's generating the audio tones. So I'm looking around for some obvious signs of electrolytic distress. Nothing's jumping out at me. And it wasn't like I was using this and I heard a pop or there was any smoke and it stopped working. It was intermittent for, I believe, and then it just stopped. So obviously power transformer power supplies might just be jelly bean analog regulators. It's not a switch mode power supply or anything fancy like that. I'm thinking there's boards on the underside, I'm not positive. And this is probably the programmable RF generator. I think this just pressure fit on there? Yes it is. I can't do anything in there. Hopefully we won't need to. So I'm guessing the test pattern instructions are stored in ROM. Could the EPROMs have gotten corrupted or something? Yeah, that would be a problem. Actually, now I'm thinking about it. Okay, so we've got EPROMs, but there's no as it is. This is all glue logic, 374s, 74HC logic series. Burr Brown digital analog converter, it looks like. So I would expect the way this works is that the patterns are generated by a microprocessor, digital analog converter, and then it's RF modulated by this stuff. So let's take a look at the other side. Okay, here's the other side. Oh yeah. Well, yeah. A little bit of digital logic down here, geez. Alright, what's this thing powered by? And a good old ADC31 Intel microcontroller. I used them way back in the day. Oh, and we have bodge wires. It's pretty ugly ones too. Check out the one on that EPROM. And a few more down here. So yeah, not the kind of thing I can just whip out a multimeter and quickly identify a problem. I mean, this is crazy, complicated. Man. So I think my best hope is to look for any caps that are bulging or leaking, and I'm not seeing any. And reseat the connectors. Other than that, I'm not seeing stuff labeled. If it was labeled, like this is plus 5 volts, this is plus 12 volts, I can check that. All this stuff's, I imagine, is going to run on 5 volts. I'm not sure what this is, an SAA1043 Phillips chip. Maybe it's a PLL or something. There's a crystal and a trimmer cap next to it. It's some weird analog stuff going on over here too. Some MC 1496s, a couple of them. Trimmer pod, a whole mess of electrolytics. And of course, an electrolytic can be bad without it being bulging or leaking. I can try to test them in circuit, but some of these, they're small and the leads are, yeah, it's not, it will be a little tricky to get in there and test, but of course not impossible. Right now, I don't have a whole lot of time to devote to doing this. I was just hoping it'd be something obvious. So I'll go through and I'll reseat the chips and reseat the connectors and hope for the best. Aha! We might have a glimmer of hope. I powered it up after wiggling everything and started smelling the characteristic smell of burning circuit board, bad electronic burning smell. And noticed it was getting kind of toasty on this guy. And look what we have down in there. We've got some nasty looking crud, burned circuit board trace. So, let us pop out the power supply board. And I looked around briefly for service info. I don't even know if it's available or ever was available for this, but it sure isn't readily available for free anywhere. So, we're just gonna go through and replace what we can see. I don't carry much in the way of low voltage, low ESR parts because I'm usually working on tube stuff. So I may or may not have something. And it might not be this cap. It could be this is bad, or we have a shorted diode or something like that. But for sure there's something bad there. So it looks like we just disconnect a bunch of stuff and we pop this out. So notice there's a regulator mounted at the side too. I guess I just decided to use the cabinet for a heatsink. I disconnected everything after taking some reference photos and pulled out the power supply board and unsoldered that cap. Here's what I found. First off, all the caps look to be high quality Nichicons, but as you can see clearly they are from 1995, so that was a while ago. Remove this cap, and underneath it the board is charred. Now the cap is not shorted, but it is, well, it's like melted or crud there, and the board is very definitely charred and smells like burnt fiberglass. So what I'm thinking is the cap leaked, and whatever leaked was conductive, and it's shorted between the two, or something like that. So I'll replace the cap, of course, but I think I better make sure I clean up that area and there's no conductivity or anything going on there. And while I have this out, I'll check other stuff too. I think all these caps are 220, 35 volt. And what about these guys? 2235, 1000 at 100. Yeah, so 4 of them are 2200 at 35. And this is new enough, they may even still make these series. I might be able to buy these exact caps. Yeah, like I said, they're high quality Nichicon 105C, but nothing lasts forever. These are 85Cs. Well, I got out my ohm meter and measured the resistance between those capacitor pads, 12 ohms in either direction. I scraped some of that charring away and it jumped up to 35. So I gotta clean all that out. It's burned almost all the way through the board. So what I suspect happened is kind of a thermal runaway situation. Probably the cap went higher in ESR, started leaking, and whatever it leaked was conductive. got onto the board, formed a conduction path, which generated more heat, more capacitor getting hotter, capacitor leaking more crud. The board starts charring, which forms carbon, which conducts, which makes more heat. And yeah, this is what you end up with. At least I do have replacements on hand. A little higher voltage than I'd like. The originals are 220 at 35, these are 220 at 63, and you might be thinking, oh, higher voltage is always better. Not necessarily, because generally the higher the voltage, the higher the ESR. Not a huge jump from 35 to 63, and they are Nichicon 105, decent quality. Anyways, that's what I have, so I'm just going to go ahead and replace all 5 of them while I've got the board out. But that's only after and if I can scrape all this crud away and get rid of that conductive path. As I'm working my way through and replacing the others, I'm finding some leakage in them as well. So, yeah, you know, I still refuse to think of 1995 as being a long time ago or old, but yeah, nothing lasts forever. So, I think it's a good idea that I'm replacing all of these. And I do recall I saw one other YouTuber working on one of these, and he had a charred area on this board, worse than mine, even. And I recall seeing somebody else post that they replaced a bunch of caps and got theirs working again. So there you have it. If you've got one of these, you might want to preemptively pull out this board and at least replace these 5 caps. Eventually I'm going to replace these 5 as well, but I need to order them up. Alright, here we go. Man, that stinks. I dug out that burnt area. That smell of circuit board. Anyways, there goes nothing. Haha. Maybe, kinda, sorta. I'm looking at the scope. It's doing stuff. Kinda crazy stuff. Kinda looks like it's coming and going. Crazy about that. No, it doesn't appear to be anything coming out of the composite jack at all. Here's the audio output. Interesting, it's clipped if I go into mono, but it looks better if I go into stereo mode. Which may lead to, there may be another indication of what I think is going on now. So, here's the power supply board recapped, reinstalled, and feeling these heat sinks. Toasty. Warm, very toasty, cold. And that's the one that was going directly to this cap. I think whatever component this is got killed. Which is not surprising at all if you think it was nearly a dead short. And I presume this is a linear regulator. It probably got cooked. So, take the board back out, check that. I think we may have to replace a regulator. It is weird though, when I first powered this back up, I saw something sporadically on the scope that sure looked like a composite video signal, but we're getting nothing now. It's just flatlined. Pulled the board back out, pulled off the heatsink. It is an LM317T. Now, I don't do a whole lot with semiconductors, but now and then I've done some tinkering, and I went digging. I was just about to give up when Score. I have 2 of them I ordered from Mauser probably quite some time ago, but it is an LM317T, so we are in business. I also popped up one of these caps just to check the condition of it. It seems to be okay. I'm going to put it back in and replace this. I checked all the 1N4004 diodes next to it, and they all check okay. So I don't really have any way of testing that easily, so I'm just going to trust my instinct and replace it. Nope, no dice with the new LM317. And actually now I'm not hearing a relay click. Normally there'd be a delay of a couple seconds when you turn it on and you hear a relay click, and that doesn't happen anymore. No click. I'm pretty sure I was getting a click before. I'll have to go back and review this when I edit the video. And I'm checking the RF out. There's nothing out of here. There's nothing out of the standard video output. The audio is still slightly clipped, and the LM317 is not getting warm. As I said, I checked the diodes next to it. I don't know. I don't think there are any fuses on this board. See some Dale precision resistors, some plastic film caps. Some AC line filter. I don't think. So I'll have to get in there and actually check some voltages, which is not so easy to do when this is all together. But well, I guess I can try that now. Now that I know it's an LM317, I'm pretty sure the pinout is starting from the left in, ground out. At least I can see if there's any voltage going in or out of it. So I'm going to set down the camera and try to do that right now. Well, crap. I was wrong with my pinout. It's 3 in, 2 out, 1 is adjust. We have 44 volts coming in, 30 volts going out. Which seems a little high, considering there were 35 volt caps in this before. Did something else get taken out with all the carnage? I don't know. Without some service data, I don't know how much more I can do. I can blindly replace these other 5 caps, check some more diodes, but I don't know what the voltage in and out is supposed to be, because nothing is labeled. I did a little more searching around online, and I don't think there is a service manual for this. There's a calibration guide, that's all I found. I did find another guy on YouTube that had one that was getting flaky, and he recapped his board, and he had the same findings with these 5 caps, that they were leaking and they smelled bad. He replaced those. He also said there was a white relay on the underside, that his was not making good contact, and I think that's the relay that's no longer clicking for me. There are several others up here as well. I believe he said that one kicks in when it has 12 volts across it or something like that. But anyways, here's what I'm thinking, that this device doesn't like something, and it's not closing a relay, and it's not putting a load on that, something like that. But without knowing what these voltages are supposed to be, it's hard for me to do any more troubleshooting other than take this board out, reverse engineer it the best I can, see what devices are under these heat sinks. Once I do, say that's a 7812, it's a 12 volt positive regulator, then I can check to see, is there 12 volts coming out of it. This is an LM317, that's an LM317. Those are adjustable. They can output something like 1.5 to 30 something volts. And the way you set that is with a pair of resistors, which I presume is what these resistors are down on the board next to it. So one other simple thing I can do is determine what values they're supposed to be and verify that they are correct. It's probably what these 2 resistors are for as well, is to set the voltage on that guy. They're so small in the way they're oriented, I can't see the values because they're printed. They don't have colored stripes on them. So I can't see the value without actually pulling them out. I gotta think about how much time and effort do I actually want to put into this. There are 2 of them on eBay right now, but they come with other stuff. One is paired up with one of these, and one is paired up with that and the 93, and they want many hundreds of dollars. I'm not willing to spend quite that much money, not at this point. So I'm going to leave off here. And, well, if anybody has any thoughts, suggestions, tips, I'd very much appreciate it. Thanks for watching.